Have you ever taken a single step on a winter morning and suddenly felt the ground vanish beneath you, as if the world itself had betrayed your balance? One moment you are confident, moving forward without thinking, and the next moment your feet slide helplessly across a sheet of ice, and gravity begins its quiet but determined work. It feels mysterious, almost unfair, like the universe briefly changed its rules just to surprise you. But what if that small moment, that simple slip, is actually an invitation to look deeper into the hidden laws that shape our everyday lives? The beauty of science, something Richard Feynman loved to remind us, is that even the most ordinary experiences contain astonishing secrets waiting to be discovered. When you slip on ice, you are not simply losing your footing. You are encountering a profound lesson in physics, a lesson about friction, motion, and the delicate balance between surfaces that allows us to walk, run, and live our daily lives without constantly crashing into the ground. Friction is one of those invisible companions we rarely notice until it disappears. Every step you take depends on it. Your shoe presses against the ground pushes back, and that tiny resistance keeps you stable. Without friction, the world would be chaos. Cars could not accelerate, pencils could not write, and even the simple act of standing would become an impossible challenge. Yet ice has a peculiar talent for weakening this essential force. When temperatures drop and water freezes into a smooth crystalline surface, something remarkable happens at the microscopic level. The pressure and slight warmth from your foot can create an incredibly thin layer of liquid water on top of the ice, a layer so delicate that you cannot see it, but powerful enough to transform the ground beneath you into something closer to a lubricant than a solid surface. Instead of gripping the ground, your shoe now glides across this microscopic film, and suddenly the familiar rules that guide your steps begin to fade away. But there is something deeply inspiring about this realization, because it reminds us that the universe operates through elegant principles that reveal themselves to those who are curious enough to ask questions. Richard Feynman often spoke about the joy of understanding how things work, not just in laboratories or equations, but in the small surprises of everyday life. A slippery sidewalk becomes more than an inconvenience. It becomes a window into the subtle interactions between molecules, temperature, pressure, and motion. When you begin to see the world through that lens, every experience becomes richer. A winter walk is no longer just cold air and careful steps. It becomes an encounter with the hidden mechanics of nature, quietly reminding you that curiosity can turn even a simple slip into a moment of discovery and wonder. But the story of slipping on ice becomes far more intriguing when you begin to question something that seems obvious. If ice is simply frozen water, solid and hard, why should it behave so differently from other solid surfaces? After all, you can walk confidently across concrete, wood, or rough stone without a second thought. Yet ice turns the same confident step into a gamble. At first glance, the explanation seems simple. Ice is smooth. But science rarely settles for simple appearances, and this is where curiosity begins to pull back the curtain. Richard Feynman loved this moment, the moment when an ordinary explanation stops being satisfying and the real mystery begins to grow. Scientists once believed that ice was slippery simply because pressure from your foot melted it slightly, producing that thin lubricating layer of water. The idea sounded convincing. More pressure meant more melting, more water, and less friction. But then a strange problem appeared. Experiments showed that ice can still be slippery, even when the pressure is too small to cause melting. Suddenly the explanation that seemed complete began to crack, and the deeper puzzle emerged. What was really happening beneath your feet when you stepped onto frozen ground? The answer hides at a scale so small that it escapes ordinary vision. Even when ice appears perfectly solid, the molecules at its surface behave differently from those locked inside the crystal. The outermost molecules are less tightly bound, vibrating and shifting in ways that resemble a thin, unstable liquid layer. It is as if the surface of the ice cannot quite decide whether it wants to remain solid or briefly relax into motion. When your shoe presses against this fragile boundary, that already mobile surface becomes even more fluid, forming a microscopic film of water that acts like nature's own lubricant. Suddenly the friction that normally anchors your step is weakened, and your foot begins to slide. Yet the suspense deepens when you realize that this invisible layer is not always the same thickness. Temperature, pressure, and the texture of your shoes all influence the behavior of that delicate boundary between solid and liquid. At very low temperatures the layer becomes thinner, making ice slightly less slippery, while near the melting point the film grows more active and the danger increases. This subtle dance of molecules is happening beneath every winter sidewalk, every frozen lake, every icy road. And most people walk across it without ever imagining the hidden drama unfolding under their boots. The wonder of physics is that it reveals these quiet secrets. A simple step becomes a story about molecular freedom, energy, and the strange behavior of matter at the edge of freezing. When you realize this, slipping on ice no longer feels like a random accident. It becomes a reminder that the universe is full of mysteries disguised as everyday experiences, waiting patiently for curious minds to notice them. Once you begin to see the hidden physics beneath something as simple as an icy sidewalk, your perspective on everyday life quietly changes. The ground you walk on is no longer just a surface. It becomes a delicate negotiation between forces, textures, and microscopic motion. Every step you take is actually a small experiment in friction, balance, and control. When friction is strong, your foot grips the ground and propels you forward with confidence. When friction weakens, the world feels uncertain, and suddenly you become aware of every movement your body makes. But this awareness carries a powerful lesson that goes far beyond winter sidewalks. Understanding the science of slipping on ice teaches you that knowledge transforms vulnerability into awareness. Instead of blaming the ice for being treacherous, you begin to appreciate the subtle mechanics behind it, and that understanding allows you to adapt. Your shoes matter because the texture of their soles increases friction and helps break through that microscopic water layer. Your walking technique matters because shorter, careful steps keep your center of gravity balanced over your feet. Even the design of tires on winter roads follows the same principle, with grooves and patterns engineered to cut through water and create grip where nature tries to remove it. This is the quiet power of physics. It does not simply explain the world, it empowers you to interact with it more intelligently. Richard Feynman often emphasized that the joy of science lies not only in solving complex equations, but in recognizing how deeply the laws of nature shape the smallest moments of our lives. A winter walk becomes an example of that philosophy in action. Instead of fearing the ice, you start observing it. You notice how sunlight softens the surface during the day, and how the temperature at night changes its behavior. You notice how rough snow provides grip, while smooth frozen patches demand caution. And slowly, almost without realizing it, your curiosity becomes a tool for survival. This is what makes science inspiring. It turns confusion into clarity and replaces frustration with understanding. The same curiosity that explains why you slip on ice can also unlock countless other mysteries hidden in ordinary experiences. The world is filled with invisible rules waiting to be noticed, and every question you ask brings you one step closer to seeing the universe the way great thinkers like Richard Feynman did, with wonder, humility, and excitement for the unknown. So the next time winter arrives and the ground glistens with a thin sheet of ice, remember that beneath your careful steps lies a beautiful piece of physics unfolding in silence. And if you are benefiting from our topics, please subscribe, like, and turn on the bell notification so you can see our new videos early.